Okay, so we're gonna make a little video here, talk about how to draw perfect cubes in perspective. We'll draw 3 or 4 in different places. Before I get started, I've kind of tried to take a little of the tack off this tape so it'll come off easy. But I wanna make sure that I tape my piece of paper down so that my paper doesn't move. I need to have my eye level extend beyond my page in order that I can have my station point far enough back that I have room to draw inside of the cone of vision. So first thing I'm going to do is put in my eye level, right? Want to be aware of what's above our eye level and what's below our eye level. I think for the purposes of this drawing, I might actually maybe bring my eye level down a little lower than I was originally thinking. I'm going to come 4 inches down the page, put a little mark on that side of the paper, and then on the other side as well, so that I can make sure that my eye level is perfectly horizontal. Okay. For this drawing, I'm using HB pencils, which give me a nice firm point so that I can not have to sharpen very much. I have a couple extras here. I have my triangles. I have a couple different erasers in case I need them. And that's basically what we'll need for this drawing, okay? And I'm gonna go ahead and label things so I can remember what they are. But this is my eye level. Represents where my eyes are viewing this scene. So everything below this level is below my eyes. Everything above, I'm below. So they're above my head up here. Also represents the horizon line, okay? And in 1-point perspective, the horizon line and the eye level are actually the same. So everything up here would be sky. Everything down here would be land or ocean or something, okay? Next thing I'm gonna do is determine my line of sight. So determining where I am from right to left. And I'm just gonna do this right in the middle of my page. So I'm gonna put a mark here at 4.5 inches. And then again up here at 4.5 inches. And that'll allow me to put in a perfectly vertical line of sight. So again, everything to the left of this is to my left, and everything to the right is to my right. Okay, and I'm going to label this LOS. I should say LOS, but line of sight. Okay, so if we were looking at a cube, if it's right here in front of our eyes, it looks like a square, but as it moves to the left, we start to see the side of the square. And then as we move this way, we start to see this side. And as we move up, we start to see the bottom, right? And so that's what we're going to try to depict in our drawings here today, okay? So the next thing we need to determine, we've determined where we are from left to right and from up and down, but we need to determine our station point. How far away are we from this? And we want to be fairly far away. I'm going to look at my tools here for a second. And I could very easily put a station point a little further down than even on my page. I'm going to go ahead and do that just so that I can have a little more room within the cone of vision. Okay. And we'll draw a cube outside the cone of vision today to kind of show you why that matters. But so somewhere down here, right near the bottom of the video screen, I'm going to put a little dot. That's my station point, or SP, and it represents how far away we are from this scene. So this is, if I was looking into this scene, this is how far away I am, okay? And real quick, again, why that matters is because we can only see for about 60 degrees in front of us. But by backing it up where I did, if I do 30 degrees on this side, this is the 30-degree angle, and then I do 30 degrees on this side. So together, 30 plus 30 is 60 degrees. And that 60 degrees is my COV, or my cone of vision. COV. So this is what I can see and have it not be distorted. Everything outside of this, out here, might be a little warped or distorted when you're drawing it in perspective. Okay, so the next thing that I need to do is at 45 degrees, and it looks like I could do this on either side. I have a little bit more room to my left, so I'm going to put my measuring point over here, but I'm also I need to extend this line out a little further. And this is the part where I don't want you to get confused. This point here and this point here aren't measuring points. We're not using that intersection. The two things that we'll use for our actual drawing in 1 point perspective, where our line of sight and our eye level intersect, that becomes our vanishing point. And then 45 degrees over from our station point becomes our measuring point that we can use to figure out how to draw a square or a cube in perspective. And so I don't need to draw this whole line, I just need to know where it intersects. It intersects right there. I'm going to put a really small dot. You don't want a big dot, because then when you're measuring, you don't know if you're exactly on it. And I'm going to mark this as a measuring point, okay? And I know we've talked about this a lot, but I'm going to review it one more time. But in perspective, if you look at the top square on this cube, if it's at my eye level, it's perfectly flat. And as we move it down and down and down and down and down, it slowly gets bigger and bigger and bigger. And when it hits the station point, that's when it's a perfect square. And that's why we need to know what our station point is. So at our station point, if we were like looking at a map, anything that was 90 degrees away from us on a map is going to go to this vanishing point. And then everything that's 45 degrees away from the station point will go to our measuring point, okay? So just to review the logic here, if I have a square, and I'm just going to trace this one real quick rather than drawing a square. But if I have a square, not in perspective, if, for example, if you imagine that I didn't know where this square ended, if I had this line here and this line here, I could still figure out where my square ended, because this corner is always going to be 45 degrees from that corner, right? And so it's the 45 degrees. And that's that logic is what's gonna help us to figure out how to make our cube in perspective actually work, okay? And you can do it either to this side or to this side, it doesn't matter. You just pick one. But as long as it's 45 degrees from your station point, in perspective, all 45-degree angles will go to either this measuring point or one that's over here that I didn't actually put in the image, okay? So that's the logic that we're using to help us to draw perfect cubes, okay? So I have everything here set up that I need. I want to draw at least a couple of them inside of the cone of vision in this area, and we might draw a couple outside the cone of vision. And for this assignment, I want you to draw at least 3 perfect cubes. You could draw one above eye level, one below eye level, maybe one that's right on the line of sight. Just draw 3 in different positions just to make sure that you've got the skill to do this, okay? So what I'm gonna do is, to start, I'm gonna just pick a random spot. I'm gonna just start by putting a cube just right here. And so I'm gonna put it, I need to make sure that I'm drawing it perfectly horizontal. So I'm gonna draw the bottom of my cube first. And I'm just gonna make a 1-inch cube. So I'm gonna draw a line from 1 to 2 inches right here, okay? So that's the bottom of my cube. And then I can put my line here. And I didn't get it quite perfectly lined up with inches, but I did get it on 1/8 of an inch. So if I go from 1/8 past 2 to 1/8 there, it's going to be exactly 1 inch. So I have a 1-inch bottom, a 1-inch side, and then I'm going to put the top in. And again, I'm using my line of sight to make sure that this is perfectly horizontal, okay? And then I can just connect those dots there with a perfectly vertical line. I'm taking advantage of the fact that my triangle has a right angle here. Okay, so what I've just drawn is like the front plane of my cube, okay? And now I've got to put in these orthogonal lines that are moving away, and they're all going to go to the vanishing point. So just to review the rules of 1-point perspective, all vertical lines are going to be vertical, all horizontal lines are going to stay horizontal, and all orthogonal lines are going to go to the vanishing point. And I don't know where it ends, so I'm going to draw it a little too long. So we've got to figure out where the back of this cube's going to be. And then I'll clean it up. Okay. And one thing that I'm going to have to do is I'm going to have to draw through. And so even though if this was like a wooden block, I wouldn't see this line, I'm still going to put it in there because we're going to need it for measuring. And I'll just draw it really light so that I could erase it later if I needed to. So I've started creating this box that's moving back to the vanishing point. So the challenge for us to make this a perfect cube is figuring out where the back of the box is. And we could just guess, but we don't want to guess, we want to know for sure. So what we're going to do is we're going to follow that rule, that logic that says if we go to a 45 degrees, we'll find the back corner. And I have a 45-degree measuring point over here. And so if I go from the front corner of this box to my measuring point, that'll be a 45-degree angle. And wherever it hits the back of this box is where it ends, okay? So very lightly, because again, this is a measuring line. It's not a part of the drawing, okay? But now that I've measured where a 45-degree angle would hit, I know right where the back of the box is. I'm going to zoom in on this because I'm done with the measuring now. But once I have that, I can just follow my rules, right? So if the back corner's here, I'm gonna have a line that's gonna go straight up because it's a vertical line. And so I don't have to measure anything. I can just use the logic of perspective and complete my cube. So it's gonna come from that little point straight up until it hits that top corner, and then it has to turn sideways, and that line has to be perfectly horizontal. So when I'm done with this cube, every line that's a part of the actual cube will either be perfectly vertical, perfectly horizontal, or they'll go to the vanishing point. I didn't draw this, but we could draw through just to show you. I can complete this box. And I'd like you to do this actually, just because it's a good habit to be in. But right there, I just found where this back corner is. And I've tried to be really careful and precise. So I could, if I trusted myself, just draw a line from this point to this point, and it should be vertical. But just to make sure, I'm gonna try to get a really nice vertical line. And they're not quite perfectly lined up, but they're not too far off. We're not laser accurate with these tools. But there it is. So we have everything we need there on our cube. We can take an eraser here, and I could clean this up. So I don't need these lines back here anymore. Just for the sake of this assignment, I don't want you to completely like make it perfect, because I want to be able to see that you're using the measuring line, that you can draw a perfect cube. Okay, so there's one cube. Let's go ahead and let's draw another one. Let's go ahead and we're going to put a cube right above our eye level. Okay, so we're just going to go above the eye level, and I'm going to make sure again that the bottom of my cube is perfectly horizontal, but I'm going to put it so it's right on our line of sight. So it's going to be right above our head like that. Okay, and I'm going to go from 3.5 to 4.5. And so it'll be a 1-inch cube. Okay, and then I can draw my vertical lines. Let's see. I'm not measuring it yet. It didn't line up with a really convenient way to measure for 1 inch. I'll measure in a second, so I'm just going to draw a little extra long, and then I can come back and get a ruler. And so now I know that it's 1 inch tall and 1 inch wide, and then I can complete my box using the edge of my paper as a guide. So I get the top perfectly horizontal as well, and I should have a pretty decent square shape there. And I can get rid of that extra line at the top. Okay, so now, again, I'm going to draw the bottom of the box, and I know it's going to be going towards this vanishing point. Okay. So these orthogonal lines are this time coming down to the VP because this box is floating above our heads. But again, we don't know where it ends yet. So we've got to figure that out before we finish our box. And then we're going to draw through. So I'm going to also draw the orthogonal lines that are on the top of the box that we just can't see. And I don't how far they'll go, so I'll draw them a little extra long. Okay, so I know somewhere there'll be a vertical and vertical lines going up and horizontal lines going across up there. But let's use the bottom of the box to figure out where it is. So again, we can use our same measuring point, but this time we're going to draw it on the bottom of the cube. And I'm just going to go from the bottom of the cube to my measuring point. Theoretically, you could also go to the top of the cube and find that one, and they should still work just the same. In fact, I might do that because this is really cramped. The closer you get to the eye level, the tighter the perspective becomes. But that's where the back of my box should be. And just for fun, let's try it from the top and we'll see if it actually works, if it lines up. It should. Okay. So if these are in the right place, this and this should be perfectly vertical. And now I have everything I need to finish my box. Okay. So if we zoom in on that. So the bottom of my box, or the back edge, is going to be where this intersection occurred right here. So there's the back of my box. And again, that space is really short because we're so close to the eye level. So the closer you are to the eye level, the flatter it becomes, and then the more you move away, the bigger it becomes. Okay. All right. And then once we know where these back corners are, we could extend them up. This is the part where I was curious to see if my precision was good enough. But if I was really precise, this dot and this dot should be really close. And they're not bad. They're not bad. So there's the back of my box. And then we'll go over from the back corner to the back corner. Keep that perfectly horizontal. And where that hits this line is where it should come down. So I'm just going to use my horizon line and match that up. And then those should actually line up, and they do. Okay, so this one was a lot more precise, a little bit harder. I'm going to get rid of my lines that I didn't need. Technically, this would be covering this line of sight. And if I wanted to get in with some line quality and really try to make it look nicer, I'd probably emphasize the outside of the box of the front plane. So we might come up and just re-emphasize the part that's closer to us so that it pops forward. And then we could take our kneaded eraser, and since all this stuff inside is kind of like our X-ray vision, we could knock it down a little bit so that the outside of the square stands out the most. Okay, but that's a perfect cube in perspective floating above our heads. Okay, so let's do one more. Let's just do a bigger one. So instead of 1 inches, maybe I'll do a 2-inch one and do it over here on the left-hand side. Let's see, do we want to go out of Kona Vision on this one. Let's try it and just see what happens. So I'm gonna do like a 2-inch box, but I'm gonna have part of it out of the Kona Vision and part of it inside the Kona Vision. So there's my 2 inches. That's the bottom of my cube. And then I gotta do my vertical. So this is 3 5/8. So I'll go to 2 5/8. Oh, 1 5/8, because this is a 2-inch. So right there, 2 inches down. Okay, and then I can just complete my box. Let's see. So that's a 1/2 inch, 5/8 plus a 1/16. Oh, it's too late for math. So I'm gonna do 1/2 inch, and I'm gonna go to 2.5 inches, and then I'm gonna add another 1/8 and another 1/16. So, and then I'll just connect that with a vertical line. There we go. Okay, so there's the front of my cube. We're gonna take our orthogonal lines back to the vanishing point. I don't know that this is really gonna look all that strange because it's still mostly in the Kona Vision, so I'll do one more really far outside the Kona Vision. All right, so again, I need to figure out where the box ends, and if I draw a 45-degree angle to this back line right here, that'll tell me where the box ends. So I'm gonna go from the front corner to my 45-degree vanishing point, and where that intersects, there's the back of my cube. And now I have everything that I need to finish this cube out, so I'll zoom in. You can see a little better. So from back here, I can take a vertical line from that back corner and bring it straight up until where it hits that. And that's the back of my box. I can bring that line over here. Until it hits that. And then go straight down. And then if I wanted to put in the back of the box, theoretically, if I followed the logic, this should be perfectly horizontal and connected. Again, there's a little margin for error because we're doing things by hand, and sometimes things are just a little off, but we're pretty dang close. So I feel pretty good about that. Okay, so there's kind of the back wall. And then if we want to go in and clean it up a little bit, we could. And I think for the most part, this cube actually, you would look at that and you'd believe that it's a cube. I'm believing that's a cube. So let's try to draw one outside the cone of vision and see if we can get it to go just a little bit strange. I totally missed on that line. Got too busy talking. But just trying to firm up the outside edges so the line quality helps it make sense. Hopefully that improves the clarity a little bit. And we could lift out and soften some of these interior lines just a little bit more. So, but anyway, there's 3 perfect cubes. And again, we used our measuring point, which is 45 degrees from the station point, to figure out where the back corner of each of these boxes were, okay? And I actually think this video is already long enough. It's at half an hour. So again, I want you to draw 3 boxes in 1-point perspective using your station point and your measuring point to create perfect cubes.